So we've gone over just regular limits before. For example, the limit as x approaches 2 of x squared, you'd probably say 4 because you're just plugging 2 for x, 2 squared equals to 4. But there are some functions, let's just call f of x. There are some functions where it's not continuous all the way through, so we need to find the limit of either the left side or right side, which basically means that most likely um, the limit as x approaches 2 of this like function that's not continuous all the way through is just going to be equal to, or just going to be, does not exist. Let me create a graph real quick. Let's just show an example. We'll say red is f of x. See, that's 1. We'll say that's 2 and negative 2. How exactly would you say the limit as x approaches 2 of this function would be? Well, before I said that it would not exist, simply because of the fact that you can't have two limits coexisting in one function. So we would say it does not exist. But say we still want to find the limit, but since we can't find it just generally, this is why we use one-sided limits. So we have one for the left side, which is considered to be negative, and we have one for the right side, which is positive. And so basically, we can just follow whatever is coming this way. Let's say like as x approaches 2 on the left side or negative, we follow it from the left side and coming in rightward, and the first line we see, we're going to follow that, and it's going to give us a limit. So what we would say of like limit as x approaches 2 on the left side, this would be equal to negative 2, because the left side comes in and it immediately we follow this line and it encloses on negative 2. So that's what we would say for the left side. And same logic goes for the right side. As we're encapsulating from the right side, we follow this line into 2. So we would say the limit as x approaches 2 from the right side, or have a positive right here, is going to be equal to positive 2. So for functions like this, where it's not continuous all the way through, as we can see at x equals 1, it's two different points, a one-sided limit is very important to use. Here's a table point of view. So basically, we see here as x approaches 5 from the left-hand side for f of x, it approaches and gets closer and closer to 75. We see here 73.51 for 4.9, and then 74.85, 74.985 for 4.999. So basically from the left side, or anything that is, I guess, less than 5, it's going to be approaching 75. And for the right hand side, as x approaches 5 from the right hand side, for f of x, the limit is going to go towards 75 as well. We see 5.1 is 76.51, 5.01 is 75.1501, 5.001 turns into 75.015.001. So despite it not being defined f5, we basically want to get extremely close to it. We don't actually want to get to 5. We want to see the limit as x approaches 5, not as as x is 5. We've talked about this before. Um, so basically for the left-hand side, it's basically less than 5. So I guess we can say x is less than 5 and approaches or increases for, I guess, for the left-hand side, or let's say like for x approaches 5, left-hand side. Actually, no, we'll just say for left side, or for left. And for the right-hand side, we see the x is greater than 5, so it is decreasing for right. And it's very important we keep this in mind because we can use this knowledge to create, I guess, tables on the spot in order for us to determine the limits. So we can say, oh, f of x, for the limit of f of x as x approaches, we see here x approaches 5 from the left side. We first count from, we get as close as possible. We go from 4.99 or 4.9 to 4.99 to 4.999, and we can see which number it gradually progresses towards, and that's what our limit is going to end up being. Same logic goes for the right hand side, but for the right hand side it decreases, so you're going to start with the value that's higher than 5, which is going to be 5.1. It's either you add 0.1 or you decrease 0.1, as you can see here, to 5. For this, it's going to be 5.1 and then 5.01, and you're going to keep adding that decimal point. And you obviously see it approach 75. So that's basically how you would do it for the right-hand side as well. Or wait, sorry, not. You just increase the decimal place more and more, and you just see it approach 75, and that's what you're gonna say for the right hand side. Left hand side, you're gonna apply the same logic. So yeah, be sure to keep this in mind. When it's a negative, it's basically you basically want to count upwards from a lower number, and if it's the right hand side, then you're gonna go higher than the number that n is, in this case 5, and you're gonna go down. So that's basically what you should keep in mind, so that you could easily solve limit problems just by using this logic. Let's go over a practice problem. Let's say we have f of x. Oops. Let's say f of x is equal to x minus 2 divided by x minus 2 right here. And we'll say, let's try to find the limit. Or actually, let's put this in a different color. Try to find the limit as x approaches 2 from the left-hand side of f of x. The limit as x approaches 2 from the right-hand side for f of x. And just a regular one where it's the limit as x just approaches 2. Try to solve the following problem without my help. Now let's try to attack this problem the same way I guess we had, I guess, through tables, which was what we were going over before. Let's clear this out first. All right, so let's create a table. We'll put it in red. Or right here. Or let's have it like this. I guess this kind of works. Say we'll separate it like this. And we'll have 2 be right here. And as you can see, we can't just plug in 2. It simply does not exist. But as we were talking about before, from the left hand side, it would basically be 2.1, 2.01, and we could do the math right now. So we do 2.1. Actually, let's do this in black. 2.1 minus 2 divided by 2 minus 2, or 2.1 minus 2. That'll be 0.1 divided by, it would be, let's see here, 0.1 divided by 0.1. So this is equal to 1. And we could, if we do the same exact thing with 2.01, it'll just be 0.01 divided by 0.01. So we could say as x approaches 2 from the left hand side, it's going to be equal to, or well, this would be the right hand side actually, because if we think back, it's going from positive to negative. 2.1 to 2. So it'd be coming from the right hand side. So as it approaches 2 from the right hand side, it is inching closer and closer to 1. So our answer for this would be 1. 1. There you go. Sorry, my handwriting's not the best. But now let's try to find it for the left hand side. We have 1.99 and 1.9. So let's do 1.9. Say 1.9 minus 2 divided by 1.9 minus 2. Of course, whatever turns negative in the numerator becomes a positive, so that would become just regular 0.1 divided by negative 0.1, which would be equal to negative 1. And if we did the same exact math for 1.99, it also equals negative 1. So since it approaches negative 1, oops, let me put it in black. We're going to say for the limit as x approaches 2 from the left hand side, we're going to say that is going to be equal to negative 1. Just by using this table, we were able to find these one-handed limits. And we already know as x approaches 2, it doesn't even exist. So we are just going to say does not exist. And this is a basic introduction to one-sided limits. And this is how you can use, one of the many ways that you could find limits as x is approaching a number from the left or right hand side.